So in looking at the differentiation rules, we're going to look at two very important ones. And these rules illustrate that for the first time, calculus is not so intuitive where everything you'd want to have happen actually does happen. So a lot of the differentiation rules we've looked at were sort of intuitive, and you know, if you were to guess what you thought should happen, that's exactly what does happen. Here's the first instance in which that's not the case. So for instance, like the product rule, many students would think, well, I mean, if f of x is equal to, you know, x, and g of x is equal to x squared, g of x is equal to x squared, then, you know, maybe the derivative of the product, maybe the derivative of their product is just the product of their derivatives. But this simple example will show us that's not the case, right? Because f of x is x, and g of x is x squared. So if we're to believe that you could just take the derivative of the product separately, well, the derivative of x is 1, and the derivative of x squared is 2x. However, we know that this is the same as the derivative of x cubed using an exponential property, or property of exponents, and we know the derivative of x cubed by the power rule is 3x squared, which suggests that this can't be true. So it is not the case that you can just take the derivative of the product separately. So we need a more a better tool, one that works the entire time, and that is the product rule, which you can prove using the definition and a little bit of trickery, which I'll omit here. But I'll do an example out for you. And then we'll look at the quotient rule, which again, what we would want to have happen is not what actually does happen. The derivative of a quotient is not the quotient of the derivatives. It's a little more complicated than that. But let's look at two examples on how to apply each of these. So let's first do the product rule. So for example, so let's say we had y equals x squared plus 1 times x cubed minus 4. All right, and so if we want to, we notice that this is a product of two functions, and maybe I'll call that one f and I'll call that one g. And so if we go off to the side here, we can see that we're calling f x squared plus 1, we're calling g x cubed minus 4, and if I look up at the product rule, I'm going to need the derivatives of both functions, so I might as well calculate them now. F prime is 2x, and g prime is 3x squared. So that means if I apply the product rule over here, y prime equals, I'm just going to copy that product rule down, f g prime plus g f prime, and now we just substitute. F is x squared plus 1, g prime is 3x squared, plus g, which is x cubed minus 4, and f prime, which is 2x. And so there is the actual derivative of that product. Now, for those who take AP Calculus, there's no need really to simplify this out. I know it probably, in all your other math classes, you were told, you know, simplify, but really you don't get any points for simplifying. I guess unless it's a multiple choice and you have to match your answer. So just leave your answer like this, it's fine. The main purpose was just to use the rule. Okay, so there's the product rule. It's actually pretty easy to remember because addition's commutative, so it doesn't even matter whether you do fg prime first or gf prime first. So just the derivative of one times the function times the other function plus that relationship in reverse. The quotient rule, it does matter because if you look at the numerator here, you're subtracting. So let's do an example of that. And let's see what that looks like. So let's take a function like y equals, take a rational function, y equals x plus 3 divided by x squared plus 1. So this is set up as a quotient, so I'm going to call this g, and I'm going to call that f. And if you look at your quotient rule, you're going to need their derivatives. So we'll make a little, we'll stay organized by going over here and saying f is x plus 3, f prime therefore is 1, and g I'm calling x squared plus 1, which means that g prime is 2x. And now we'll just apply the quotient rule. So y prime is going to be, so if I look at my quotient rule up above, I'm going to have to take the denominator function and square it, and then I'm going to times it by g f prime minus f g prime. So we plug in what we have here. The denominator is g squared, so that's x squared plus 1 quantity squared. And then I see g again immediately in the numerator, x squared plus 1 times f prime, which is 1. And then I subtract f, which is x plus 3, times g prime, which is 2x. And once again, so we're done. There's no real need to simplify unless you're just so you care so much about how things look that you just need, you can't help it, but you need to simplify this. So if you're that person, go ahead and feel free to simplify it. But otherwise, it's fine. This is the derivative of that quotient. And again, if it's a multiple choice, you'd want to make sure you simplify so you can find your answer choice. So there's two examples using the product rule and the quotient rule. These will have to be memorized unless you want. I mean, rederiving them is just not feasible. So you'll need to memorize these if you want to be successful in your calculus course. So, make note cards or do whatever you have to do.